All right, in this video, we're going to go ahead and take a look at how to solve logarithmic equations, more specifically, natural logs equations using the one-to-one property. And so basically what we're looking at is this business of right here, is that if we are going to go ahead and we can get the natural log, okay, so basically the natural log of A equals the natural log of B, then A equals B, which makes sense because they have to be equal to one another on either side, no matter if you're taking the natural log of them or not. So our mission then is to take these guys right here and get a natural log equal to a natural log, and then be able to get rid of, and if we focus our attention here, get rid of those logs and then just say A equals B and then solve from there. So let's go ahead and do that. All right, so here we go. First things first is that I look at this guy right here and I say to myself, oh boy, I got two natural logs over on the left-hand side. That's not good. So what I want to do is collect them. And I'm going to collect them using the product rule that is down below. So if we look right here, okay, is that I know, oh, look at that lightsaber, that this guy right here plus this guy, I could collect them by doing the product of those particular terms. So that means is that I could go this times this and take the natural log of both those, and that will collect them down to one log. So let's do that. So I'm going to go, oops, that is the wrong marker. Let's go the natural log then of x times x over 2 equals the natural log of 8. Okay, so far so good. And what I want to do next is I want to then kind of simplify things up and go the natural log of x squared over 2 equals the natural log of, oops, I don't want that, the natural log of 8. And so now, since if I look over in this direction right here, okay, is that if I have the natural log, again, of something equals the natural log of something, I can get rid of the natural logs and then just say that and set those equal to one another and solve. So let's take advantage of that. So here we go. I got the natural log of something and the natural log of something. So I can set this equal to that and basically knock it out from there. So let's go ahead and take a shot at that. So that means is that I'm going to go x squared, okay, divided by 2 equals 8. And from here, we got some algebra to do, okay? So that means is that I'm going to multiply each side by 2. Those are going to cancel out. And I'm going to get x squared equals 16. And then I take the square root of each side. But I got to remember when I'm taking the square root of each side and canceling out an even power, that's going to give me x equals plus or minus 4, okay? And so what we need to do is that at this point, we need to check our solution. So when we're solving natural log equations or log equations in general, we want to make sure that when we plug things in, okay, that is going to, we cannot take the log of a negative number. And when I say log, that counts for the natural log as well. So going on over here, I have this business of, okay, well, which one of these is going to work? So let me put these in two places here. Okay, and so what I want to do is that just draw your attention to, if I look at plugging a 4 right here with the lightsaber into this and this, notice that that would give me a positive value right here, and this would give me a positive value. So I know for sure that this is legit, okay? So that's one of our correct answers. But if we go on over to this business of a negative 4, if I plug a negative 4 in right here, I'm going to get a log of a negative number, which we know is going to go ahead and be, I can't scroll this down, is going to go ahead and be the bad. You can't take the log of a negative number, and so therefore it is rejected. Okay, so our only solution for that guy is going to be x equals 4. Okay, so we got to be able to check our answers, and we got to be able to condense each side to a single natural log so we can set them equal to one another. Let's take a look at that next example. Okay, so here we have a little bit of work to do, and when we're doing that, we want to go ahead and keep in mind that we got to condense each side down to a single log, and even with no coefficients in front of the log as well. So we got some work to do right here that we're going to take a look at, and then we're going to solve it out and see where this takes us. So first step, and I'm going to try and get as much economy out of this as possible, is that I know that I have something that is going to be in front of the natural log right there. And so remember how we deal with that is that we're going to do the power rule. And so anytime that I have a number, right, or something that is going to be in front of this log, we can pop it up there so it appears here. And that gets rid of the coefficient. So let's do that. And so here we go. This guy, oops, that is the wrong button, Dennis, and is going to pop up right here. And I know that these guys right here are going to, when we're looking at this, we got this business of a subtraction sign. So if we got the difference, I could take the difference of each one of those and turn it into a quotient. So that combines it down to one log on that side, and so that's going to be really important so we can apply the one-to-one property of logarithms. Okay, so here we go. I'm rewriting everything as the log, natural log of, x to the third equals the natural log of 8 over 27. Okay, now that I have the natural logs that are going to go ahead and be equal to one another, there's no coefficients, and it's just natural log and natural log, I'm going to go ahead and drop the natural log, and I'm going to go x cubed equals 8 over 27. And then I'm going to take the cube root of each side, however that you see this out, and I'm going to go cube root and cube root. And so remember, the cube root basically means is that if I'm doing this out right here, okay, these are going to cancel out each other. So if I take the cube root of a perfect or a cube, if you will, then that is going to go ahead and just leave me with this cube equals. And so looking at each part of these, okay, oops, I don't know why I undid that. Let me go ahead and do that again. So that's going to be x equals. And now I got the cube root of each one of these separately, okay? And so that means is that I can say on this right-hand side, the cube root of 8 over the cube root of 27. So that's going to tell me the following things. What number multiplied by itself 3 times is going to equal an 8? And what number multiplied by itself 3 times is going to give me a 27? And so for those of us that know our powers very well, we can say, well, 2 times itself 3 times is going to give me an 8, and 3 times itself 3 times is going to give me a 27. And so therefore, we know that this is going to be our answer, okay? Remember, when you're taking odd powers to each side, such as what we did right here, okay, you don't need the plus or minus sign. However, if you're taking the even powers to knock things out, you do need to go ahead and do a plus or minus sign with that, okay? So that's how you do the one-to-one property, and I will see you in the next section.